Let us try to see this example. Let x be an absolutely continuous random variable and suppose its PDF is given by this. One can easily check that this is a proper PDF. That means it is non-negative, and if you integrate minus infinity to infinity fxx dx, this is 1, and this is non-negative also. One can easily check that. And suppose I want to find the PDF of y is equal to x square. So in this case my gx is x square. Now note that in this case my support is, because if x lies between -1 to 1 or 1 to 2, I can find a neighborhood so that if I integrate PDF in that neighborhood I will get a positive quantity. So my neighborhood turns out to be closed 1, closed -1 to closed 1. So what I have to do is first find the PDF of y and hence find the distribution function of y. Then I have to find the distribution function of y and hence find the PDF of y. So you can get the PDF, you can get the distribution function from PDF in the first example. From the in the second example you have to find the PDF by first finding the distribution function. So let's try to see how does it go. As I said, my Sx is -1 to 2, sorry, because it is up to here 2. Sx is -1 to 2. Now I have to see whether Gx is monotone. Its derivative is 2x, so it will be monotone for x positive, monotone increasing for x positive and monotone decreasing for x negative. So I break it into two parts. So -1 to 0 where it will be monotonically decreasing, and 0 to 2 where it will be monotonically increasing. So I have broken the support of x into two parts. Let me call these sets as S1x and S2x, where S1x is this set, S2x is this set. I know that in S1x it is strictly decreasing, in S2x it is strictly increasing. So it is strictly monotone in each of these sets S1x and S2x. My Gx is x square. So let us move to the next slide. So I make a table because k is equal to 2. This is a situation where I have a k is equal to 2. S1x is this, S2x is this. What is the inverse image over here? My Gx was x square. So inverse image would be minus root y. Here inverse image would be root y. I look at derivative of g1 inverse y, which is -1 upon 2 root y, which is clearly continuous, d by dy of g2 inverse y, which is 1 by 2 root y. You see, there could be a problem at y is equal to 0, but in absolutely continuous case I do not really bother too much about single points, because there I can always change the PDF. So for all practical purposes I can take this to be continuous, because it is continuous in 0 to 2 except at y is equal to 0, and that point I can always forget because it is absolutely continuous case. Let us consider g of S1x. G of x is x square. So when x square takes the set -1 to 0 to 0 and 1, x square takes the set 0 to 2 to 0 to 4. So g of S2x turns out to be this. Now y is in g of S1x if and only if y is between 0 to 1, y is in g of S2x if and only if y is between 0 to 4. So what I have to sum two quantities, I have to sum fx g1 inverse y mod of dy dy g1 inverse y. I have to take this and I have to sum it with fx g2 inverse y mod of dy dy g2 inverse y. But g1 inverse y is same as minus root y, so this is this fx minus root y. Then derivative of this, so which is -1 by 2 root y. Now g of S1x, indicator function of g of S1x, g of S1x is 0 1, so indicator function of 0 1. Now here g2 inverse y is root y, so fx root y. d by dy of g2 inverse y is 1 by 2 root y, so mod of 1 by 2 root y. Indicator 0 to 4 y, because indicator function of g of S2x is 0 to 4. So the PDF turns out to be the sum of these two quantities, and that is what I write down over here. Let us try to see what is happening. This is getting sum with this. So this is a non-negative quantity, sorry, a positive quantity if y is between 0 to 1. This is also a positive quantity when y is between 0 to 1. So that is why when y is between 0 to 1, both of these would contribute. So I am considering, that is the reason why I am considering y is equal to 0 to 1 separately. when y is between 0 to 1, root y is between 0 to 1 minus root y is between minus 1 to 0. So what I am considering? I am considering fx of gi inverse y, which is in this case is fx of minus root y. But minus root y is between minus 1 to 0. So I want to see what is the PDF when argument is between minus 1 to 0. So let us try to see what is the PDF when argument is between minus 1 to 0. When argument is between minus 1 to 0, the PDF is mod of the argument divided by 2. So the first part would give me mod of square root minus square root of y by 2 for y between 0 to 1, and then it turns out to be 1 by 2 root y plus, let us look at when y is between 0 to 1, fx is root y is between 0 to 1, so I have to see what is a PDF when the argument is between 0 to 1. When argument between 0 to 1, again PDF is mod of x by 2. So it is same as mod of the argument, which is mod of root y divided by 2 into 1 by 2 root y. So what happens, it becomes root y gets cancelled because minus, with the modulus minus root y would becomes root y, so you get 1 by 4 plus 1 by 4, which is 1 by 2. So that is what you get over here. Now when y is between 1 to 4, you see I am not bothering about these singleton points, whether one is included here or one is included over here. I can include one here also. When y is between 1 to 4, only this would play the role. Now y is between 1 to 4, that means root y is between 1 to 2. So I have to look at, so this is not contributing when y is between 1 to 4. I look at fx root y when argument is between 1 to 2. So let us go back. When argument is between 1 to 2, fxx is argument divided by 3. So this would be same as argument divided by 3, which would be same as root y divided by 3 into 1 by 2 root y. So root y gets cancelled and you are get with 1 by 6. So it is this. And all other places the PDF is 0, and that is what it says, at all other points the PDF is 0. So you have got the PDF of y. Now once you have a PDF of y, finding distribution function is very easy. So I find out the distribution function of y. So probability fyy is same as probability y less than or equal to y, which is minus infinity to y fy t dt. Note that for y less than 0, so if this quantity was less than 0, so I have to integrate from minus infinity to y. Now if this y was less than 0, so I have to integrate the PDF from minus infinity to something which is less than 0. But in such a range, my PDF is 0 because it is taking positive value only between 1 and 4, 0 and 4. So that is why this would be 0 if y is less than 0. If y is greater than or equal to 4, you integrate out the whole PDF, because if y is greater than or equal to 4, then 4 is over here, y is over here, you integrate the whole PDF because your PDF is positive only up to 4. So integrate whole PDF, so that means you get 1. So these two cases are trivial. Now let us look at when y is between 0 to 1. Then fyy is same as probability y less than or equal to y, which is same as, because up to 0 the PDF is 0. So if I integrate PDF up to 0, it will be 0, then 0 to y. Because this y was between 0 to 1, so that means I have to look at PDF when the argument is less than 1. When argument is less than 1, PDF is half. So that means I integrate is half and you get y by 2. Now if y is between 1 to 4, that means you have to integrate the PDF from minus infinity, 1 is over here and y. That means you have to integrate PDF over here, up in this range. But PDF in the range minus infinity to 0 is 0, so that will contribute 0. Then you have to integrate from 0 to 1. 0 to 1 the PDF is half. Then you have to integrate from 1 to y, and y is less than 4. And in the PDF, when the argument is between 1 to 4 is 1 by 6. So that means 1 to y 1 by 6 dt. Now if you integrate this turns out to be y plus 2 by 6. So I found the PDF, I found the distribution function. This is 0 if y less than 0. This is y by 2 if y is between 0 to 1. And this is y plus 2 by 6 if y is between 1 to 4. And this is 1 if y greater than or equal to 4. So I have found out the distribution function using the PDF. Now let us just try to find out the distribution function directly, and then I will try to find out the PDF. Now note that my y is x square. Now note that my Sx was minus range of Sx, if you look at it, was support of Sx was minus 1 to 2. So my Sx is minus 1 to 2. So this suggests that Sy would be nothing but 0 to 4 because y is x square. So clearly if y is less than 0, probability y less than or equal to y, which is f by y, is probability x square less than or equal to y. But if y is less than 0, x square cannot take a negative value, so this probability would be 0. For y greater than or equal to 0, f by y would be probability x square less than or equal to y, which would be same as x lies between minus square root y to plus square root y, which would be same as integrating PDF from minus square root y to square root y, fx dt. Now note that my PDF is in branches. It is mod of x by, so let us try to see mod of x by 2 if x is between minus 1 to 1, x by 3 if x between 1 to 2. So my fxx is mod of x by 2 if x is between minus 1 to 0, and x by 3 if x is between 1 to 2. Right? So I have to integrate this PDF. Now it will depend where my y is. If y is between 0 to 1, so root y will be between 0 to 1. So this is a minus 1, this is a 0, this is a 1. So if root y is between 0 to 1, so minus root y would be between minus 1 to 0. So the PDF, so in this minus root y to root y lies between minus 1 to 1. And in this case, sorry, this is x lies between minus 1 to 1. In this case, I know my PDF is same as mod of t by 2. So if you integrate this turns out to be y by 2. Now if y is between 1 to 4, f by y would be integrating this over here. Now in this case, root y lies between 1 and 2. So 0, 1 and 2. So root y is over here. Here is minus 1, minus 2. So minus root y is over here. So minus root y is here, root y is here. So f by y would be how much? I integrate the PDF, but PDF before minus 1 is 0. So that means it would start from minus 1. It would go up to 1 because up to that point the PDF is x. This whole I have to integrate, so it becomes mod of t by 2 dt. Then I have to integrate from 1 to root y. 1 to root y is less than 2, so it would be t by 3 dt. So if you found it out, this turns out to be y plus 2 by 6. So we have found the distribution function, and clearly for y greater than or equal to 4, f by y is 1, because then you integrate the whole PDF of x. So that's the distribution function of y turns out to be this quantity 0. If y less than 0, we have found it out before. Between 0 to 1, we have seen it is y by 2. Between 1 to 4, it is 1 by 4. When greater than or equal to 4, it is 4. So I found out PDF. Now one can see that this function is differentiable everywhere except possibly at the points 0, 1 and 4. So to see whether it is absolutely continuous or not, I try to differentiate it wherever it is not. So I try to define gyy, which is fy prime y for y not belonging to 0, 1, 4 and 0 otherwise. And then I get to see whether when I integrate this, if this turns out to be 1, then I can say that y is of absolutely continuous type, and my PDF would be this. One of the PDFs would be this. And that is what exactly I'll do in the next slide. Sy we have seen is 0 to 4. Fyy is differentiable everywhere except at point 014. I define gy, which is derivative of Fyy when y is not in 014, and I take it to be 0 otherwise. So when you differentiate Fyy, this is 1 by 2 if between 0. So let us see how does Fyy is. So its derivative here is 1 by 2, its derivative here is 1 by 6. So 0 to 1 derivative is 1 by 2, 1 to 4 derivative is 1 by 6, rest of the places derivative is 0. So 1 by 2 if y between 0 to 1, 1 by 6 if y between 1 to 4, 0 otherwise. One can easily check that minus infinity to infinity gy dy is 1. So if you integrate this function, this turns out to be 1. So thus y is absolutely continuous type with a PDF given by this. The reason I am calling a PDF because even if I make it like this would also be a PDF, because in absolutely continuous case the PDF can always be changed at any countable number of points. So let me now give this take home problem. Let x be a random variable with PDF given by this. One can check that this is a PDF, it is non-negative. If you integrate it from minus infinity to infinity, you get 1. Now I define y is equal to 2x plus 3, so my gx is 2x plus 3. So repeat the last exercise, find the PDF of y and hence find the distribution function of y. Find the distribution function of y and hence find the PDF of y. Now in the first case, note that this g is strictly increasing in whole R. So it will be strictly increasing in my Sx. So what is my Sx? Sx here is 0 to infinity. So it is strictly increasing, so I have to use the result for k is equal to 1. What would be the G inverse y? G inverse y would be nothing but y minus 3 by 2. What would be my Sy? Y is 2x plus 3, so Sy would become 3 to infinity. So what would be my PDF of y? Fx G inverse y mod of d by dy of G inverse y, which is 1 by 2, then indicator 3 to infinity. That is the PDF. Once you have a PDF, you can find the distribution function of y. Now one can get the directly distribution function Fyy as probability that 2x plus 3 less than or equal to y, which is same as Fx of y minus 3 by 2, because this is same as probability x less than or equal to y minus 3 by 2. You know the PDF of x, so you can find the distribution function, so you can get this distribution function. Now once you have this distribution function, you can find the PDF. Now before I conclude, let me give a summary of the things I will be doing in the next module. So suppose x is a random variable associated with a random experiment E. Now each time the random experiment is performed, we get a value of x. So I have a population of values of x. I want to get on an average what will be the mean of that population of values of x, which is equal to saying that suppose if the random experiment is performed infinitely, what is the mean or expectation of observed value of x or gx for some function g. That is what I want to know. Let us try to interpret this from the relative frequency approach. So in the discrete case, the relative frequency interpretation of probability suggests that we take expected value of gx to be limit n going to infinity, because I am performing the experiment large number of times, summation x belonging to Sx, gx is the value I observe for g. Then I may have observed this value x a large number of times, more than one times, so I have to see how many times I have observed the value x equal to x. Each time the contribution of g is gx, so this is the contribution of gx corresponding to the value small x. I sum over x belonging to Sx divided by n. Now this limit can be taken inside, so this becomes this. Now this quantity is frequency of x equal to x. So this is a frequency of x equal to x divided by n. But by relative frequency approach, this is same as probability x equal to x along with this. So that is what probability x equal to x. So this becomes summation x belonging to Sx, Gx, Fxx. So this is the weight to this value is given by Fxx and Gx is the value. So mean or expected value of Gx in discrete case can be defined like this. So in the continuous case, similarly one can possibly define expected value of Gx to be minus infinity to infinity Gx Fxx dx. So this summation gets replaced by the integral sign. So we will introduce the concept of expectation in the next module. And the motivation we have provided over here. So I'll take these as the definitions of the expectations. And then we'll discuss various properties of expectation. So this is all for this module. Wish you all the best and have a great day.